Hello, Subhajit. Good evening, Somujit. Good evening, Sudipa. Good evening. Please tell your friend Sudipa to join the class. Hello. Sudipa, please tell your friend to join the class. Okay. So if this is the day 3 of ANOVA, day 4, I think day 3, day 4. This is the mistake. This is the day 4 ANOVA. So if H0 is rejected, then the problem is to find which groups or group responsible for this rejection. Here we discuss this type of test is called post hoc test. Called post hoc test. Here we discuss only one post hoc test, but there are several post hoc tests like 2K test, Cephei test, Duncan test, and here I use Fisher-T test. Okay. Fisher-T test. So this post hoc test used only when H0 of ANOVA, that means all means are equal, is rejected. In that case, we need to find which pairs or which group or groups are responsible for this rejection. So suppose, so we know this is the ith group name. We already defined this thing in our previous class. And yi naught minus yj naught, which is the estimator of alpha I minus alpha j hat is follow. When sigma square is known, this follow alpha I minus alpha j sigma square 1 by ni. Ni is number of observation under group I, and Nj is the number of observation under group J. So this follow normal 0, 1. If sigma square is unknown, and we know the sigma square is estimated by MAC, mean sum of square due to error, and then this follow T distribution with n minus k. N minus k is a degrees of freedom of the distribution of SSE. So this is for T distribution with n minus k degrees of freedom. So if you want to test, so here our hypothesis alpha I equal to alpha j versus h1 I j, alpha I not equal to alpha j. So for this our test statistics is and underration of this test statistics we follow n minus k degrees of freedom, where n is a total number of observation, k is number of groups, which we defined in our previous class. So please go attending this class fast, please go to the previous class also. Okay, thank you. And we reject H naught if at level alpha if mod t greater than t alpha by 2 n minus k, where t alpha by 2 n minus k is a alpha by 2 a percentile point of T distribution with n minus k degrees of freedom. Okay. So, and otherwise, we accept it. So this is the decision rule. But here we see that if for each pair we use label alpha, then overall type 2 error, overall type 1 error, overall probability of type 1 error should exceed greater than alpha. So for this reason we use Monteroni correction. So according to Monteroni correction, alpha is your family wise rate. Error rate, and alpha star, which is your pairwise error rate. Then this alpha star should be alpha by root over alpha by k, alpha by kc2. So kc2 is a total number of pairs which have to be compared. And here I not equal to 0. So in that case, this critical value should be changed. Instead of this, we use alpha star by 2. Instead of alpha, we use alpha star by 2, and other things are same. That is n minus 1. So in that case, alpha star by, if you use alpha star by 2, then this problem overall type 1 error should be less than equal to alpha. So for this reason, here we use alpha star instead of alpha. So this is due to Monteroni. So this is for Monteroni correction. So when you use Fisher p-test, we should use Monteroni corrections. So now, if all the observations, all the number of observations under each group is same, that means n1 equal to n2 equal to nk, since we use k number of groups, which is equal to n0 say. So in that case, this test statistics t is equal to in that case ni equal to nj, so this is 2mc divided by n0. So we reject h0 mod t is greater than t alpha star by 2. This is a critical region. N minus k. So this is equivalently yj naught greater than t alpha star by 2 n minus k root over 2 mac by n, and this is called critical difference or least significance difference. So if your number of observation under each group are same, that means the balance case. In that situation, we see that this portion is fixed for all ij pair. So because it does not depend on ij, in that case this value is called critical difference or least significance difference. In that case, you just compute all the pairs, pair difference, that is yi naught minus y naught, yj naught bar I not equal to j, I less than j. Just compute these portions. So and then compute this value and verify whether this difference is greater than or not. If this difference for any pair, the difference greater than this means this the pair corresponding pair is significantly different from each other. Okay. So please tell me, have you any question or queries regarding these portions? If yes, please tell me. Do you have any questions? Shudipa, Shubrojit, Shomujit. So if you have any queries or questions, please write in the comment section. I will answer it. Or other who watching this video, please also write your queries in the comment section. I will answer it. So have you any question? Please tell me. Otherwise I wrap this portion. Okay. Thank you, Shudipa. So I wrap this portion. Now consider a practical example and okay for me. We should close it. So this will be an example. Following are the speeds in km per hour of cars on 4 different types or road condition or fuel using some some test. So no, okay, you can. Now the question is, to test if the road conditions differ with respect to average speed. And the data setter So these are the data set. And for solving this question, so first we start with the module. Let Yij, this is denoted the jth speed of, so speed of jth car, sorry, this is speed of jth car, this is not a jth speed, speed of jth car when road condition is type I. So j from 1 to n and I equal to 1 to 4, and here ni is a number of observations under type I. Hence n1 equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. n1 equal to 11, n2 equal to 3 equal to, again this is 9, n4 equal to, and n is a total number of observation which is a sum of this 4, that means 11 plus 9 20, 29 plus 8, that is 37. Okay, and k number of groups, this is equal to 4. So model is and mu equal to alpha equal to additional effect due to type I with sum over Ni alpha I equal to 0. Eij random error corresponding Yij assumption or assumption. Eij follow Iid normal 0 sigma square, where sigma square is unknown. Here null hypothesis H naught equal to alpha 1 equal to alpha 2 equal to alpha 3 equal to alpha 4 versus alternative hypothesis at least 1 alpha I, 1 alpha I is different from other. Now computation part. Ti naught denoted as total under type I. This is equal to Yij j from 1 to ni by this is total, that means this is only summation j from 1 to ni Yij I from 1 to 4. So that means just sum of this give T1, sum of this give T2, and sum of this give T3, and sum of this give T4. Okay. So first you do this part. Next, SSD sum of square between group is equal to I from 1 to 4 Ti naught whole square by ni minus g square by ni, where g is a grand total and this is equal to sum over I from 1 to 4 j from 1 to ni yij. So just adding all t1 plus t2, all ti's, that is t1 plus t2 plus t4, this is the grand total. And I define n is the total number of observation, which is nothing but a n1 plus n2 plus n3 plus n4. In that case, here n is 37. Okay, so SSB is this with degrees of freedom 4 minus 1 equal to 3. So similarly you compute MSB, which is equal to SSB by divided by corresponding degrees of freedom, that is 3. So similarly SST, sum of square due to total, this is equal to yij square minus g square by m. So this means just 77 square plus 70 square plus 63 square plus 84 square and so on. Just do all these things, then you get this value, and then you subtract this value from square minus n and you get SST, sum of square due to total, and the corresponding degrees of freedom is n minus 1. And we know SST is a sum of SSB plus SSE. So then SSE is equal to SST minus SSB with degrees of freedom n minus 1 minus k minus 1, that is n minus k, and MSE SSE by n minus k, F ratio MSB by MSC. Now from table F table, you can find critical value. Alpha is a pre-assigned value. Generally we take alpha equal to 0.05. If alpha is not mentioned in the question, in that case we take alpha equal to 0.05. Otherwise you can take alpha 0.05, 0.10, 0.01. Okay. So for given alpha, I assume, since alpha is not provided in the example, I assume alpha equal to 0.05, and in that case we compute alpha 0.05. This is 3 because k is here 4, so degrees of freedom for SSB is 3, and n minus k, n is a 37 and k is 4, that means 33. So from table you can find this value. If table, for this you can use biometry table, otherwise you can use R code. I take 4 decimal place, so I use round comment, round QF 0.95 3,33, 4 decimal place. So if you use this comment, you can get this value. Now, if you observe a F value, that means F ratio, greater than this critical value, this is called critical value, then we reject H0 at 5% level of significance, and in that case your conclusion all there is sufficient evidence to conclude that all 4 road conditions are not same. Are not same with respect to their average respect. And then we need to perform post-hoc test. We discuss post-hoc test. We already discussed. Hope you can come to. For critical value for post-hoc test, you can use T table, or otherwise you can use R comment. I use 4 decimal place, so round QT, and since here 4k equal to 4 and 4c2 equal to 6, we need to compare 6 pairs, so our alpha star is 0.05 by 6. So alpha star by 2, that means 0.05 by 12, and this T degrees of freedom of T here is 34. So if you use this comment, you can get this critical value, and using this critical value you can compute the critical value for this post-hoc test, and using this critical value we can find out which pair or pairs is responsible for this rejection. Okay, so if this is less than critical value, then the conclusion is then we do not reject H0 at 5% level of significance, and we conclude that there is insufficient evidence to conclude that all 4 road conditions are not same with respect to their average, and in that case we do not need to this post-hoc test, because here we find H0 accepted. In that case we do not use post-hoc test. Okay, So please tell me, and you complete this computational part in your home and submit within a week. Okay, so this is your homework assignment. R is you can find R on net. You can easily download. You do not need to pay for this R. Okay, it is totally free software, statistical software. So just using this R, you find this critical value, this and this, and you can remaining question you can compute by hand. Okay, so please tell me, have you any questions regarding this homework? Polomi Jana, Sudipa, tell me. Another, if not, then I wrap this portion. Okay. So last part means switch part. If just tell me, I go very slowly. Now if 8 is less than critical value, this part is telling about this part, yes or no? Just mentioning the last part means which part? Tell me. Just 8 ratio less than critical value. Follow me? Are you hearing me? Follow me, tell me, the F ratio less than critical value, this part? Yes, okay. So, if F ratio less than critical value, in that case, we do not reject H naught at 5% level of significance. So, your conclusion should be, there is insufficient evidence to conclude that all 4 load conditions are not same with respect to their average. Because our claim is, this is the claim which is your research hypothesis, the load condition differ with respect to average speed. So this data does not provide sufficient evidence to accept this claim. So for this reason we can conclude this in that way. Okay. So since we fail to reject H naught, this means we do not perform post-hoc test. Okay. And here I mentioned that since we fail to reject H naught, but in reality it may not be true. In that case, type 1 error may be committed. And if a ratio greater than critical value, in that case we reject the H naught, but in reality it may not be true. In that case, type 1 error is committed, and if a ratio greater than critical value, we fail to reject H naught, but H naught may not be true. In that case, type 2 error committed. First case is type 1 error, second case is type 2 error. Okay, follow me. Follow me, happy? If not, I again explain this thing. Okay, I have no problem. Please tell me. Follow me, Jana. Are you hearing me? If you satisfied, then okay. Otherwise, if not, no problem. I can again explain this thing. Follow me. Okay, thank you. So, go to the next portions. Note. Contrast in one-way fixed effect model in one-way layout. A contrast among the main effects nuance is alpha equal to sum over Ci mu I from 1 to k. And since it is a contrast, this means with sum over Ci I from 1 to k should be 0. Note that variance of alpha hat, this is equal to sum over I from 1 to k Ci square variance of yi naught bar whole square, because yi is yi naught bar, okay. Since yi's are independent, so we can get this. And we know mu hat, mu I hat, we know this mu I hat least square estimate of mu I. This is nothing but a yi naught bar. Okay. If you do not consider additive constant, that is mu. Okay. Just your model is yij mu I cross yij. So in that case, variance of L hat is this. And this is equal to sigma square I from 1 to k Ci square by Ni. And since sigma square is unknown, and I denote this variance of L hat by sigma L square, and since sigma square is unknown, then sigma L hat square, and we estimate sigma square by MAC, so this is equal to MAC into sum over I from 1 to k Ci square by Ni. Okay. And we know, suppose we want to test H naught L equal to L naught versus H1 L naught equal to L naught. In that case, test statistics T equal to L hat. L hat means sum over I from 1 to k Ci mu I hat, and since mu I hat is a y naught bar, so this is equal to, this is sum over I from 1 to k ci yi naught bar. Okay, so L hat is this minus L naught root over MSC sum over I from 1 to k ci square by n. This is follow T distribution with n minus k degrees of freedom when A is not is true. Next note, in one way fixed effect model that is Yij mu plus alpha I plus Eij, where we assume that this Eij follow normal 0 sigma square independently or identically independently distributed, and J equal to, that is the unbalanced case, I from 1 to n, and I equal to 1 to k. Without the, this is comma, not full stop, comma, without the side condition, sum over n alpha I from 1 to k, which we assume that this is equal to 0. If this, without these conditions, question is what are the estimable function. Note that sum over I from 1 to k, j from 1 to n, Aij, expectation Yij is equal to sum over 1 to k, j from 1 to n, Aij mu plus alpha I. So this is equal to if it is estimable Ci mu plus alpha I from 1 to k, then C equal to sum over Aij, j from 1 to ni. So it is better to say where C equal to this. So thus the estimable functions are the totality of of functions psi of the form psi equal to sum over ci I from 1 to k mu plus ci alpha I from 1 to k. So to consider this term is nothing but a xi. Okay. Note that neither is any parametric functions of mu alpha 1 alpha 2 alpha k estimable, nor is sum over sum over I from 1 to k in alpha. So a linear functions of the alpha x will be estimable if and only if it is in the form sum over ci alpha I from 1 to k with sum over ci equal to 0 I from 1 to k. Hence, without side conditions, only parametric contrast are estimable. Because summation alpha ci alpha is estimable where summation ci equal to 0, that means the contrast is estimable. So we can conclude that hence without side condition only parametric contrast are estimable. So this is note 4. Note 3 I think, okay. This is note 3. So show that if the total number of observations to be taken is fixed, the average variance of the estimator of all elementary treatment contrast of the effects due to the levels of the factors is minimum. If the number of observations for each level is same. Elementary contrast, we know elementary contrast means mu I minus mu j, where I from 1 to I not equal to j. So these are elementary contrast. And we know the least square estimator are yi naught bar minus y j naught bar, and their variances are, we already computed this, and their variance is 1 by ni plus 1 by nj. Okay. Therefore, the average variance G bar, which is equal to sum of I not equal to j, variance of yi naught bar, y j naught bar, and here the total number of variances used is n into n minus 1. Sorry, k into k minus 1. K into k minus 1. So this is equal to and since sigma square and this is equal to k minus 1 I from 1 to k 1 by n plus k minus 1 sum over j from 1 to k 1 by n into k minus 1. So this is simply we write 2 into k minus 1 I from, because I and j are dummy variable, so this gives this k into k minus 1. So this is nothing but a 2, sorry, please add sigma square here. So 2 sigma square I from 1 to k 1 by ni by k minus 1. And since ni's are positive, so we use arithmetic mean greater than equal to harmonic mean on applying on, and the values are 1 by n1, 1 by n2, 1 by nk. So therefore this bar, this is equal to get this value so if you apply this value, then arithmetic mean means 1 by ni by k, and harmonic means is k by sum over I from 1 to k ni. Okay. So therefore, if you apply this thing, so this is greater than equal to 2 sigma square into k sum over I from 1 to k ni by k minus 1, and this is equal to 2 sigma square n naught, where n naught is k into sum over ni by sorry, this is a mistake. I think it should be please rectify this thing. I think this should be sum over n here. Okay, so we write this thing is 2 sigma square by n naught, where n naught is equal to sum over ni k minus 1 by k. So, and this equality holds if and only if all ni's are equal, that means n naught. Hence, we can conclude that the V-bar average variance is minimum if and only if ni equal to n naught for all I from 1 to k, and minimum value is two sigma square by n naught, and in this case estimations and testing based on the estimates are efficient if ni equal to n naught for our line. So because here the average variance is minimum, so we can conclude that the estimation and testing based on these estimates are efficient. Okay. So please tell me, have you any question or queries? Can I rub this portion? Can I rub this portion? Tell me. Follow me. Sudipar, Subrojit, Somojit. Please tell me. Okay. Okay, Somojit. I think you can understand these portions. Clear? I think you can understand this portion. Yes or no? Somojit? Subhajit is okay. I am only concentrated on Somojit because he has a question. Please tell me, Somojit. Can you agree with that? Because here number of pairs is, since I not equal to j, that is k into k minus 1. So average variance of is sum of I not equal to j, variance of yi naught minus y bar j naught divided by k into k minus 1. Agree? So from this we can get this value. Okay. Now since here I not equal to j, so this means I not equal to j means this sum repeated k minus 1 time. Okay, and break this thing. One to k, 1 by ni, j equal to 1 to k, 1 minus, since I not equal to j, so subtract one thing, that is minus 1. Okay. So similarly you can do this thing for this part. J from 1 to k, these are the dynamic variable. I from 1 to k minus 1. So this gives you, because 1 plus 1 plus 1 up to k, that gives you k, so it is k minus 1. Similarly you get this value, if this value gives you k minus 1. So hence k minus 1 sigma square sum over I from 1 to k 1 by ni plus I from j from 1 to k 1 by nj divided by k into k minus 1. Okay, so this is equal to sigma square, because these are dummy variables, so we can write this thing 2 into sum over I from 1 to k 1 by ni by k. So now since n1, n2, nk both are, because these are the replications, so it should be greater than 0. So this implies 1 by n1, 1 by n2, 1 by nk. This is greater than 0. So we can apply arithmetic mean greater than equal to harmonic mean for the variables 1 by n1, 1 by n2, 1 by n3. So arithmetic mean for this case is sum over 1 by n, 1 by k, I from 1 to k. So this is greater than equal to k sum over I from 1 to k n. So this is equal to so if you use this thing here, you get this is greater than equal to 2 sigma square k into sum over I from 1 to k ni. Okay. So this give you summation ni in and I take if n is divisible by k, I assume that n is divisible by k. So this is the condition, it is required in that case. So n by k we can take n naught. So this is equal to 2 sigma square n naught. Okay? And equality holds, we know, for arithmetic mean equal to harmonic mean when ni's are all equal. That means if all ni's are equal, that means n1, n2, nk, and since n equal to sum over ni, I from 1 to k, so this equal to, suppose if you take ni equal to n naught, then this is k n naught, so n naught equal to ni, which is n by k, because this is divisible. So this is equal to k by n by k for all I from 1 to k. So equality hold when ni is equal to n naught. Okay, Shomajit, please tell me, have you any queries? Shomajit, please tell me, have you any queries? Shomajit. Okay. Thank you, Shomajit. I define now I give some definition. First, observational contrast. Let y1, y2, yn be n observations. The linear function L CIYI I from 1 to n, where CIs are given number given numbers such that sum over I from 1 to n Ci equal to 0 is called a contrast of yi's or an observational contrast. Now next definition, orthogonal contrast. Two observational contrast say L1, which is equal to I from 1 to n CIYI, you can write C curl Y curl, C curl prime Y curl, and another contrast L2, which I write I from 1 to n DI YI. So this is equal to D curl prime Y curl, and since these are the contrast, it should satisfy sum over Ci I from 1 to n equal to 0 and sum over Di I from 1 to n equal to 0 are said to be orthogonal contrast if C curl prime D curl, that means summation Ci Di I from 1 to n equal to 0. When there are more than two contrast, these are to be mutually orthogonal if they are orthogonal pairwise. For n values, there exist n minus 1 orthogonal contrast. For example, take n equal to 4, the observations are y1, y2, and the 4 observations are y1, y2, y3, y4. Then following are mutually orthogonal contrast. So please check. These are the mutually orthogonal contrast. Please check. This is your homework. Okay. Next definition, treatment contrast. Or sometimes it's called parametric contrast. A contrast among the parameter beta 1, beta 2, beta k is linear function of the beta i's, that is sum over I from 1 to k beta I, ci beta I, sorry, ci beta I, its known contrast coefficient, that means its summation ci should be 0. So in that, this is called treatment contrast or parametric contrast. For example, I take k equal to 4, that means we have beta 1, beta 2, beta 3, beta 4. So beta 1 minus beta 2, beta 1 minus 2 beta 2 plus beta 3, beta 1 plus beta 2 minus beta 3 minus beta 4. These are all example of treatment contrast. Elementary contrast. Contrast like beta I minus beta j are called elementary contrast. That is a contrast L C curve prime beta curve with contrast vector C card consisting only two non-zero elements is called a elementary contrast. Result: any treatment contrast can be expressed as a linear combination of the elementary treatment contrast. Good. Consider general contrast. The general contrast L, which is equal to sum over I from 1 to T Ci beta I, where sum over Ci I from 1 to T equal to 0, then you can write L as C1, C2, beta 2, Cp beta P. So we write L as C1 beta 1, C2 beta 2, Cp minus 1 beta P, and since this condition is hold, so this is equal to Cp minus I from 1 to P minus 1 Ci. So this is equal to minus I from 1 to P minus 1 Ci beta P. So this is C1 minus C1 beta 1 minus beta P, C2 beta 2 minus beta P, plus Cp minus 1 beta P, sorry, this is beta P minus 1, please correct this thing, beta P minus 1 beta P, which is a linear combination of the elementary contrast. So today I want to stop here. Next day I will discuss one-way ANOVA random effect module. So please submit your homework before coming Monday. We will meet again on Monday, same time, that is 6 p.m. So please tell me, have you any queries? If not, I will end this trip. So please tell me, have you any queries? Otherwise I want to end the stream. So thank you for your participation. So please tell your other friends to join this class, join this live class. Okay. Okay, Shudipa, thank you. So next day we will discuss random effect model, one-way ANOVA random effect model. And your job is, please submit your homework. I will provide you the link within 2 days. So please submit your homework, okay, before coming Monday. One-way ANOVA random effect model. This is the next day topic, okay. So thank you everybody. Shomoli, thank you.